To start graphing this ellipse, I'm going to first notice that I'm in standard form. X and Y are both squared. I'm equal to 1. This is a form that's, I think, the easiest to use to graph the ellipse. So first thing I'm going to note is where the center of the ellipse is located. The center is going to be composed of the h and k values. The h is the number with x, the k is the value with y. Since x is by itself, that has a coordinate of 0. Y is then going to be 5. I'm going to switch the sign around. So the center of my ellipse is going to be at the point 0, 5. So let's get that point plotted. 1, 2, 3, 4, 5. So right there. Next up, I'm going to find the a and the b values, which I think of as the long and short radius, although technically I guess we should call them the semi-major and semi-minor axes. So the a squared value, the way I do it at least, is always the bigger value. The b squared value is always the smaller value. So in this case, a squared is 36 and b squared is 9. Which means the a and the b values, if I take the square root, a is going to be 6, which is, I think of it as the long radius again, the semi-major axis. The b value is going to be 3, the distance from the center to the co-vertices. So the way I'm going to use those then is, since the 36, the a value, is underneath x, that tells me that my ellipse is going to be stretched more in the x, or the horizontal direction. So from where we left off, from the center, let's count 6 spaces to the left and right. So 1, 2, 3, 4, 5, 6 would be right there. That's going to be one of your vertices if we want to start checking some of these things off that we're finding. We found the center, we're finding the vertices right now. I would plot that point, or I'm sorry, write down the coordinates of that point. So 6, 5 right there. If I count 6 spaces to the left, 1, 2, 3, 4, 5, 6. And again, that's going to be the vertex. Your vertices are always along the longer axis, the major axis. That's the point -6, 5. All right, next up, let's plot the b value. Since the b value, the smaller number is under the y, I'm stretched less in the y, or vertical direction. So I think of it as the short radius. The way we'd graph a circle, we'd have 2 radii. It's just they're different lengths in an ellipse. So from the center, count up 3, 1, 2, 3. That's going to be called the co-vertex, or the co-vertices. That would be at the point 0, 8, if I want to label that right away. Similarly, count down 3 from the center. So 1, 2, 3. That's going to be at the point 0, 2. And so let's do our best now to make a nice round-looking ellipse. I'll do my best to draw that on the screen here. So I'd say that's decent. So there's my ellipse. Let's see, I've got the center, I've got the vertices, I've got the co-vertices. Last up is let's find the foci, or foci. There's some debate on how you want to pronounce that out there, whatever. As long as you know it's the plural of focus, go with it. Maybe saying focuses would be better at this point. But the foci or the foci. To do this, we're going to have to find a third value back here. That's the c value. C is the distance from the center to one of the foci. So the equation we use is c squared equals a squared minus b squared. So let's go ahead and find that c value then. C squared, the a and the b squared are both at the top already. So a squared was 36, b squared was 9. So 36 minus 9. That gets me 27 when I subtract. If I then take the square root, I'll go ahead and break that square root of 27 down. To keep this exact, at least for now, we'll probably need to go ahead and make decimals before we're done with this. So it looks like c would be equal to 3 times the square root of 3, 3 root 3, which is great and accurate, but it's not super helpful for graphing if I want to graph the foci in my graph. So let me show you a couple ways that how we're going to go about doing this. First of all, the foci are always located along the major axis. So whether that happens to be the horizontal or vertical axis, it just depends. Since I'm more stretched in the horizontal direction, my foci are going to be along that horizontal axis. So let's see. The way that I want to graph these points, I can see that no matter what, I'm going to be counting up 5 spaces because I have to be along that axis. So when I label these, I know the second value in my ordered pair, it's going to be something, 5, because I have to count up 5 to get to that location. So I think what I'll do then is from the center, since C represents the distance from the center to the foci, I think I'm just going to say, well, it's 0 plus the square root of 3, 0 plus 3 root 3, and then 0 minus 3 root 3. I don't really need that 0 in front, so I'll just use those as my initial coordinates. So I'm going to count, square root of 3, I'm going to count 3 root 3 over, and then up 5, and then negative 3 root 3 over, and then up 5. The problem is, I don't know how to count 3 root 3, so I guess even though those are nice, exact, accurate answers, I guess if I want to plot this, I'm going to probably want some approximate answers. So let's use a calculator and find out what 3 root 3 is as a decimal, and similarly negative 3 root 3. And if I do that, I see that that point's approximately 5.2, comma 5 if I use a calculator, and then obviously negative 5.2, comma 2. And so those actually I can plot, and I can make sure that those do end up inside the ellipse. So if I count over 5.2 spaces, that would put me 1, 2, 3, 4, 5. And then up 5 spaces would put me on the major axis. So right about there, really close to the vertex. And then over here, again, count 5.2 spaces over, and up 5 would put me right about there. So there are my 2 foci labeled in my graph, the exact and the approximate answers, my co-vertices, my vertices, my center, and of course the graph of the ellipse.